So our lesson today is about Ohm's Law. At this point, your teacher should have given you all the notes that are in front of you. What I encourage you to do is to watch this video. Take the notes as I take the notes. If you have questions, rewind it and watch parts over and over again. So our topic today is going to be about Ohm's Law. Now for the last week in class, we've been talking about voltage and current. Now Ohm's Law simply explores the relationship that exists between voltage and current. Because voltage and current are connected. Now when we look at them, we're able to figure out the resistance of the circuit, and that's really what we're trying to do here. So what is the idea of resistance? If the analogy we've used all along is that when you have people walking around a mall, I'm going to try that again. So what is resistance? All along we've been using the mall analogy to describe circuits. And along with the mall analogy, we said that current is sort of like people running around this mall spending their money in terms of voltage. Now if you think about running around, you can think that there are some places that have really high friction and really low friction. You could be running on ice where there's no friction, you could be running really fast or skating along. Meanwhile, you could be running through the mud, the sticky mud, and you'd have a really hard time moving. That's the friction between your feet and the ground. It's sort of preventing you from going fast or going slow. Well, that's the idea with resistance. Resistance looks at wires and how much the electrons have the ability to flow. So like I've said, this is a mathematical thing. If we look at the underneath on your page, you'll see this part about equations. Now the equations for Ohm's law is that resistance is equal to voltage divided by current. So the I stands for current, and we measure that in amps. V stands for voltage, and we measure that in V. Now R is a new one too. That one is resistance. And that's measured in ohms. Now we draw the ohm symbol the same way you draw the Lululemon symbol. And the way it's pronounced is O-H-M, ohm. Now we're going to be doing a series of mathematical things involving electricity over the next couple days. No matter what, we're always going to follow the process known as guess. It's a 5-step process. If you follow these 5 steps, you're going to get the questions and you're going to get them right every time. The first thing we do whenever we get any mathematical problem is we look at the G. We look at the givens. So we look at what information is given to us within the question. Up next would be U, and this is known as our unknowns. From there, we list what the appropriate equation is. Now today we're only going to be working with one equation, but as we go into more videos, there will be more equations that we're going to work with. So we list out our equation just with letters. And once we've listed it out with letters, we go to our next step, S, which is substitute. And what we do is we take our information from the givens and from the unknowns, and we plug them into our equation. And from there, we solve the equation. And we write ourselves a final statement. So let's look back at your note. There's the first example there. Example 1 says, what is the voltage drop for a light bulb that draws 20 amps of current and has a resistance of 10 ohms? So what information are we given here? We're told that we've got 20 amps of current. So let's list that down. Current equals 20 amps. We're also told that we've got a resistance of 10 ohms. So therefore, we can also list this down. What are we missing? Well, we're looking specifically for voltage. So there's where our question mark is. The equation we're going to use that has current, voltage, and resistance is R is equal to V over I. Now we can plug those numbers in. 10 is equal to voltage over 20. Now at this point we want to solve for voltage. So we need to get rid of this 20 right here. So we're going to multiply this side by 20. If we multiply the right side by 20, we have to multiply the left side by 20. So our next line will be 20 times 10 is equal to V. 20 times 10 is 200. So therefore, the voltage of the light bulb is 200 volts. So let's try one more example as a group. What is the resistance of the kettle that when plugged into the wall draws 12 amps of current? Well, what information are we given? Well, we're given that the kettle uses 120 volts. So let's list that as our piece of information. And we're also told that it draws 12 amps of current. So let's also list that down. What are we looking for in this question? We're looking for the resistance of the circuit. Yet again, there's only one equation we can work with right now, and that is resistance is equal to voltage over current. Let's plug those numbers in. Now when we put 120 divided by 12, our resistance is equal to 10 ohms. So therefore, the resistance of a kettle is 10 ohms. At this point, I encourage you to try the questions. The answers are already posted on e-learning for you to take a look at, and your teacher has a copy of it as well.